Now let's look at a solution using the stack data structure. For solution, first we want to iterate through the string. Next, when we see open brackets, we want to push them onto our stack. Then, when you see closed brackets, you want to pop from the stack and ensure that the bracket that we just popped off is a matching open bracket to the closing bracket that we just encountered. However, if the stack is empty, then that means that there are no open brackets left and we actually have an invalid parenthesis. And we want to continue doing this until we are finished with iterating through the strings, and then we have to ensure that the stack is empty at the end. Otherwise, if the stack is not empty, that means that there are unaccounted open brackets, and therefore this parenthesis is invalid. Now, we'll go through the previous examples using the solution that we have just proposed. In this example, we have the opening normal bracket, the opening square bracket, the opening curly bracket, then the closing curly bracket, closing square bracket, then opening square bracket, closing square bracket, and lastly, closing normal bracket. And we're saying that this is a valid parenthesis. And we'll actually verify that that is true using the framework here. First, our character is the normal bracket. Because this is one of the opening brackets, we'll push them onto a stack, and this character will end up here. For our next character, we have the square bracket. And because this is one of the opening brackets, we'll also push them onto the stack, and this character will end up here in the stack. And for the third character, we have the opening curly bracket. And because this is also one of the opening brackets, we also push them onto the stack, and this character also ends at the top of the stack. Now, this is where it gets interesting. For the fourth character, we encounter a closing bracket. So then we must pop the top element off from the stack and compare if the closing bracket matches the opening bracket. And indeed, we actually see that the brackets match because they're both curly brackets. And for the fifth character, we have the square bracket, which once again means that we must pop off the character from the top of the stack and then do comparison. And when we do comparison, we also see that this closing bracket matches the opening square bracket that was just popped off. Now moving on to the next character, we have the opening square bracket. Because this is an opening bracket, we push them onto the stack, and this character ends at the top of the stack. And for the next character, we see a closing square bracket. And then what we do is we pop off the bracket from the top of the stack and do comparison. And once again, the brackets match because they are both opening and closing square bracket. And lastly, we encounter this closing normal bracket. So now we pop off the top element from the stack again and do comparison. And once again, we actually see that those brackets actually match. Now in the end, we have no more characters to go through and our stack is empty. Therefore, we can actually verify that this is a valid parenthesis. Now we'll go through another example in which we have an invalid parenthesis. Here we have four characters that starts with opening normal bracket, followed by an opening square bracket, followed by a closing normal bracket, and lastly, we have a closing square bracket. So now let's analyze this example using a proposed solution. Here, our first character is this opening normal bracket. Because this is one of the opening brackets, we push them onto the stack, and this character ends at the top of the stack, as we see here. Next, our character is an opening square bracket. Once again, because this is one of the opening brackets, we also push them onto the stack, and this character now becomes the new top of the stack. For a third character, we have a closing normal bracket. This means that we must pop off the top element from the stack and do comparison. However, when we do comparison, we see that this bracket and the opening square bracket does not match. So because it does not match, we can conclude that we have an invalid parenthesis. Now let's review this solution as a coded solution. In this solution, our method is called the isValid method, and it takes a string called s. And this string s is an array of characters. Next, we want to iterate through each character in the string s. And for each iteration, we want to do the following operations. First, we want to check if the character is one of the open brackets. And if the character is one of the open brackets, then we append that character onto the stack. Next, we want to handle for the cases in which the character was not one of the opening brackets. In which case, first, what we want to do is we want to see the size of the stack. If the size of the stack is empty here, that means that we already have an imbalanced parenthesis in which the encountered closing bracket cannot be matched with the corresponding opening bracket, and therefore, if that turns out to be the case, then we return false. Otherwise, we move on to check if the closing bracket has a corresponding opening bracket. So if the encountered closing bracket is the closing normal bracket, then we want to pop the top element off from the stack and see if that is the corresponding opening bracket. If that doesn't turn out to be the case, then we have an invalid parenthesis. And we also do the similar checks for other types of brackets. So for curly bracket, we also want to pop the element off from the top of the stack and see if that element is equal to the opening curly bracket. And if that is not true, then we return false. And lastly, once again, we also do the similar check for the square bracket. So if the popped off top element is not the corresponding open square bracket, then we return false. And we want to continue this iteration until we either return false or reach the end of the string. And at the very end, we want to do this one last check to see if there are any elements left in the stack. If there are any elements left in the stack, that means that there are some parentheses that have been unaccounted for, in which case we have an invalid parenthesis. However, if the stack at this moment is actually empty, then we actually have all the parentheses accounted for, and therefore we have a valid parenthesis.